Hey folks, I'm about to share with you a bunch of fun things about statistics and R at the same time. And why wouldn't I use both? I mean, they do go together like chocolate and peanut butter if you think about it. Anyways, so here we go. I have written out some numbers here. I have a variable x, and I want these numbers to be stored in x, so I use the less than and the dash. It's like an arrow. I think the equal sign does work also, but for now I'm just going to do it in like traditional R notation. And you need a little c at the beginning of the parentheses. Okay, now let's try to do a few things with the values that are in x. One thing that we might like to find is the median. So we'll go print median of x. And here we go. I'll go ahead and run it. And over here we get the median value of 79. It's kind of nice that we didn't have to do that. R did it all for us. Now, you well know that when you go to find the median of a set of numbers, you know that you first have to sort them in order from small, well, in either order you want, smallest to biggest or biggest to smallest, either way. Sometimes we like to have numbers sorted and do other things with them besides just find the median. So I'm just going to, just a quick aside here, R will also just sort the numbers for you if you wanted to see them in a sorted order. So if you just go sort x, print sort x, and hit run, you'll see that the numbers are ordered from least to greatest. Yay! And like so many computer programming languages, sometimes there's additional options where we can do extra tricky stuff. So if we wanted to make it so that the order was decreasing from greatest to smallest, we just say decreasing equals true. And you'll notice it's really important that I use all uppercase for the TRUE, and that gives me a red color code, and that just lets me know, REPL just lets me know that that it recognizes that as a value true for decreasing. So if I go ahead and run it now, I go from 84 to 71. Yay. Okay, anyways, this is just a trivial little aside. I just like the idea of kind of learning neat little things, tips and tricks that you can do with programming languages. Okay, so let's find some more statistical things that we're concerned about. There are some new things that you should have learned just prior to watching this video. And one of them is called, well, there's an upper quartile and there's a lower quartile that are associated with medians. Let's go ahead and try to find the upper quartile and the lower quartile. So we're going to go print, and then we're going to go something like quantile, for some strange reason, of x, and then we're going to go ahead and print. So when I do this, I get the median again. And the quantile actually gives me a bunch of stuff. It shows me the median at the 50% mark, and then it shows me a 75 at the 25% mark and an 82 at the 75% mark. The 25% mark and the 75% mark, those are known as quartiles. What it means is that if I look at the 75 in this data set, 25% of the data will be below that value. And if I look at the 82 in this data set, 75% of the data will be below that value. Now, it won't work that way exactly for such a small data set, but if we had lots and lots of numbers, then it would be exactly true. Okay, in general, the idea is that a quartile, the lower quartile or the Q1 is normally going to be at the 25% mark, and the upper quartile or Q3 is going to be at the 75% mark. Okay, so quantile gives us all of that at once, so that's pretty cool. Now, there is another way to get those numbers. There's actually 5 numbers here, and it is something that is commonly referred to in statistics as the 5-number summary. And it turns out that R has a 5-number command, a 5-number function that will take a set of data and give us the 5 numbers. So I'm just going to go ahead and type 5num and then x, and I'm going to go ahead and run this. and it gives us the numbers, but it gives it to us in a slightly more friendly way than the quantile does. See, the quantile tells us where the 25% and the 75% is, but unfortunately, the quantile doesn't make it very easy to work with the individual numbers. See, what we'd like to be able to play around with the quartiles. We'd like to be able to play around with Q1 and Q3. And so in order to do that, we'll use 5num instead of quantile. Now, in order to pick out the Q1, one thing that we can do is we can say Q1 equals 5num, one thing I have to do first, I have to do this. I am going to make a new variable, and I'm going to call it fnum, and I'm going to set that equal to 5num of x. Okay. Now I can go ahead and take fnum, and I can take the I'm going to use square brackets now. I can go ahead and take the second number in fnum. You can see here's the first number, here's the second number. I'll take the second number and I'll store that in Q1. Remember, I said that at the 25% point, it'd be a 75, so that's what should be stored in Q1. And then for Q3, I will take fnum and I will take the fourth number right there, and I do that by using square brackets and the number 4. Okay, now that gets me Q3 and Q1. Now, there is something that's very interesting that we use in statistics. One thing that we really like knowing about a set of numbers is we like to know where the center is. But we also like to know where how spread out the numbers are. And so when we're talking about the median, the way we measure something called the spread is through something called the IQR. And the IQR is known as the interquartile range, and essentially it's just Q3 minus Q1. So I'm going to make a new variable called IQR, and I'm going to set it equal to Q3 minus Q1. Now, I'm partially doing this because I'd like to write a program to give me all this information, and I'm partially doing it to familiarize you with these terms and give you a sense of what happens when these numbers up here change to these things down here. Okay, so now we've got some really cool things going on. Now, all of this relates to how we would like to visualize this data. See, when we go to visualize data, one way that we visualize quantitative data, quantitative single variable data, is using a histogram, and another way that we like to visualize single variable data is using something called a box plot. And it turns out that a box plot is very closely related to the 5-number summary. And that's why we need the Q1 and the Q3. We don't have to have the IQR for the box plot, but we'll see if we can relate it to it. So anyways, we're going to go ahead and generate a box plot, and the good news is R does all the work for us. So I'm just going to go ahead and type box plot, and we're going to do it for X. So I'm going to go ahead and hit run, and when I do, first of all, I should get, you'll notice that I did all these calculations and no numbers appeared here. I forgot to put my print commands. But the box plot looks like it worked because I have a PDF over here. So let's take a look. And voila, there's our box plot. Now, something I'd like to point out is that the way the box plot works is the median, this bar right here in the middle, that's the median. And that bar can be near the top of the box or near the bottom of the box, but it'll still be the median. And in this case, the median is at the 79 mark because the median of our data is 79. The top bar is the upper quartile, or Q3, and it's at 82, and that's where our upper quartile is. And the bottom bar is at about 75, and that's the lower quartile. And that's where Q1 is at 75. And then down here, this would be the minimum data. This would be the minimum value of all the data in our set. And this, by the way, is known as a whisker. And this other whisker up here is the maximum data in our entire data set. So if we go back to look, we should see that something like 71 is the smallest number, and there it is, and 84 is the largest number, and that looks to be true. So this is one way to represent an entire data set with just one simple diagram. And it doesn't matter how many numbers there are. There could be hundreds of numbers here. This would still summarize the entire data set. Now, something that's not entirely intuitive is that notice how we have the percents up here? Well, each quartile is at at a 25% mark, so 25% or 75%. And then really technically the median is like quartile 2, although we never call it that. Anyways, so I want to point out that between 82 and 84 is 25% of all the data in our data set. And between 75 and 71 is also 25% of the data in our data set. And I want you to notice that it doesn't look like there's the same amount of data here as there is here. And that is something that we just have to get used to when working with box plots, is that you can have a whole lot of numbers between these two, even though the range of numbers is not very large. And you can have very few numbers between these two, even though the range of numbers is a little longer. And by the way, as long as I'm mentioning the word range, a lot of times we use the word range in statistics to describe the difference between the largest number in our data set and the smallest number. So when we look at a box plot, at least when we look at what this is called a standard box plot. When we look at a box plot, we can pretty quickly figure out what the range of the data is. Okay, I'm giving you a ton of information. I'm packing it all in. Let's go a little bit further.